Nearly 200 earthquakes were recorded in Yellowstone National Park in the past 2 weeks.
We end here tonight with a sleeping giant, an ancient super volcano.
The strongest quake to hit in the Rocky Mountains is centered just a few miles from the park. The effects would be significant.
And the next earthquake could do anything, including shut it off.
Known as the sleeping giant, Yellowstone Park is responsible for one of the most catastrophic climate events in history. In the 1950s, a major earthquake occurred that took millions of lives. Just recently, hundreds of earthquakes and tremors rocked the Yellowstone area. This raises concerns that a larger event could be on the way, and it has raised a threat to human existence. What caused Yellowstone's hundreds of earthquakes? Could this be a sign that a bigger earthquake is coming? Join us in this video as we examine the park officials' reports about hundreds of earthquakes that hit Yellowstone. Yellowstone Park struck by hundreds of earthquakes. Officials report that Yellowstone has experienced hundreds of earthquakes. Located in the northwest corner of Wyoming, Yellowstone is the first national park in the United States. This large park around Montana and Idaho is known for its wildlife and many geothermal features. It also has several biomes and rocky areas. Historically, Native Americans have lived in the Yellowstone area for at least 11,000 years. Organized exploration did not officially begin until the late 1860s. Every year, Yellowstone is subjected to numerous minor earthquakes that are usually undetectable to humans. The majority of these earthquakes occur along a hidden fissure from a significant eruption that occurred 2.1 million years ago between Hebgen Lake and the Yellowstone caldera. The forces beneath the park's surface are responsible for these little tremors. They remind us of Yellowstone's potential for eruptions and assist in preserving the regular eruptions of Old Faithful and other geysers. A 3-month period in 1985 saw 3,000 small earthquakes in the park's northern region, known as an earthquake swarm, which was caused by the Yellowstone caldera's slight sinking. There were 16 minor earthquakes with magnitudes up to 2.7 on April 30th, 2007. There have been 70 recorded instances of these earthquake swarms between 1983 and 2008. Over 250 earthquakes, the strongest of which had a magnitude of 3.9, occurred beneath Yellowstone Lake in 4 days, in December 2008. In 2 days in January 2010, there were over 250 recorded earthquakes. The seismic activity in Yellowstone is continuously monitored by the Earthquake Hazards Program. Since 1973, there have been nearly 48,000 earthquakes in the Yellowstone area. More than 99% of earthquakes are of magnitude 2 or less, and no one felt them. Only one magnitude 6 earthquake occurred during that time, and that was the M6.1 Norris earthquake of 1975 in Norris Geyser Basin, the largest earthquake recorded in Yellowstone National Park. In addition, there were 2 magnitude 5 earthquakes. Earthquakes in the Yellowstone system are primarily caused by 2 systems: a volcanic system that stresses the Earth's crust, and a tectonic system that appears to be an active extensional zone from east to west. Yellowstone earthquakes tend to occur in swarms that are close together in time and space. This scenario is related to the migration of volcanic fluids through many microscopic cracks in the shallow rocks above the ash observed in volcanoes around the world. Tremors occur along crustal cracks when there is sufficient stress due to crustal movement and volcanic activity. The rock along these faults is prone to sliding or breaking. Then the energy is released through shock waves that resonate around the surrounding rock. It can be felt when the shock wave reaches the ground. Surface waves affect the earth, which can cause it to roll, crack, or move vertically and laterally. The structures are vulnerable to earthquake damage because ground movement is mostly horizontal. Earthquakes in Yellowstone help maintain hydrothermal activity by keeping the pipeline open. Unless relatively small earthquakes cause periodic disturbances, mineral deposits can plug small cracks and channels that feed hot water into geysers and hot springs. Some earthquakes cause changes in the geological systems of Yellowstone. Earthquakes such as Hebgen Lake in 1959 and Bora Peak in 1983 significantly affected the Old Faithful geyser and other bodies of water. Earthquake swarms, successive earthquakes in a limited area within a short period, are common in Yellowstone. The largest swarm occurred in 1985 when more than 3,000 earthquakes were recorded in 3 months in the northwestern part of the park. Between Old Faithful and West Yellowstone near Lake Village, hundreds of earthquakes were recorded during the 2009 swarm. Scientists believe that the plumes are caused by changes in pressure in the Earth's crust caused by the migration of hydrothermal fluids, a natural occurrence of volcanoes. The plumes help map and understand the underground geology around and below Yellowstone. Earthquake energy moves through hard and molten rock at different rates. By reading seismic waves generated by earthquakes, scientists can see the surface and create visualizations of the magma chamber and caldera. An extensive geological monitoring system has been established to facilitate its interpretation. On the surface, the region has a peaceful outlook, but it is home to more than 10,000 hydrothermal vents and ridges, the largest concentration of such phenomena on Earth. Beneath these stunning landscapes and natural wonders lies a geological wonder that has fascinated scientists and terrified millions of visitors. This vast desert is more than 2.2 million hectares and is more than a dream destination for photos and vacations. It is a living, breathing testament to the raw power of our planet. It's also a way to explore and understand the inner workings of the Earth. At the core of Yellowstone's appeal is the Yellowstone caldera, a colossal crater-shaped can. Every 90 minutes to 2 hours, the caldera releases hot water and steam into the air. This unique personality and pattern of eruptions is particularly attractive to visitors. In addition to geysers, the Yellowstone caldera is a kaleidoscope of hot springs, bubbling, and mud flows. These hydrothermal features are fueled by heat released from the caldera's magma chamber, located just a few kilometers below the Earth's surface. As the water flows through the fractured rock layers, it heats up to over 200 degrees Fahrenheit before erupting in brilliant color and texture. One of the most fascinating sights in the Yellowstone caldera is the Great Prism Spring, a huge pool of turquoise water covered in bright orange, yellow, and green bands to the United States, and witness the otherworldly beauty of geothermal activity. The volcano that formed the Yellowstone caldera was one of the most cataclysmic volcanic events in Earth's history. How did it happen? What were the after effects? The volcanic climax of the past million years. The dark history of the Yellowstone caldera began about 640,000 years ago. It was the culmination of 3 monumental eruptions over the past 2.1 million years, each more powerful than the last. The first of these eruptions, the Huckleberry Ridge eruption, occurred about 2.1 million years ago and created a caldera more than 60 miles wide. A second eruption, the Mesa Falls eruption, occurred 1.3 million years later, forming the Island Park caldera and the Mesa Falls Tuff. However, it was the latter event, known as the Lava Creek eruption, that caused the Yellowstone caldera that we know today. This latest deep eruption threw an astonishing 240 cubic meters of rock, ash, and volcanic gases into the atmosphere, covering large areas of the continent in ash and changing the world's climate for years. The scale of this event is almost immeasurable, with ash capable of burying cities and countryside and disrupting agriculture and infrastructure on an unprecedented scale. Recent discoveries have revealed that there are 2 magma chambers under the caldera. The deeper chamber is 4.5 times larger than the first. These chambers are filled with molten rock that feeds geysers, hot springs, and mud puddles. When you think about the magnitude of the creation of the Yellowstone caldera, you can't help but wonder what would happen if such eruptions occurred today. Apart from eruptions, tremors are commonly associated with the park. It's been an increasing occurrence in the park, and it sure has a history about it. The most dramatic earthquakes in Yellowstone Park. One major seismic event that shaped Yellowstone's landscape was the Hebgen Lake earthquake of 1959. This terrifying event is a powerful reminder of the power and unpredictability of the Earth's tectonic forces. August 17, 1959, was a quiet day until violent convulsions broke the silence on the Earth. The Lake Hebgen earthquake shook the area with a magnitude of 7.3. The aftermath of the earthquake was devastating, triggering massive landslides, destroying roads and bridges, and claiming the lives of 28 people. This earthquake destroyed the Hebgen Dam, which triggered a flood that inundated the landscape and permanently changed the course of the Madison River. The epicenter was outside the western boundary of the park. In an instant, the earth began to ripple like the waves of a stormy sea, unleashing unimaginable chaos. It left the Madison River Dam, creating a new body of water now known as Quake Lake. The previously dormant geysers suddenly erupted in a rhythmic cycle. Roads and bridges became impassable and buildings were destroyed. Amid this chaos and destruction, communities came together and helped rebuild. This event is a sobering and refreshing reminder of the importance of preparedness and vigilance. After this incident, the vulnerability of the area was thoroughly assessed. This led to significant changes in controls, building codes, and emergency plans. Knowing the impact this event could have on the world, it is commendable that a group of extremely talented scientists worked tirelessly to keep us informed not only in the United States, but around the world. Scientists and researchers at the EVO seismographic stations of the Yellowstone Volcano Observatory and the University of Utah work to monitor and mitigate the park's risks every day. Their efforts, with a combination of cutting-edge technology and unwavering dedication, form the park's backbone. The two institutions are tasked with monitoring the subtle movements and seismic rumblings that reveal the restless sleep of the volcanic system of the parks. Using a network of seismometers, GPS receivers, and other monitoring devices scattered throughout the park, these organizations provide real-time data and analysis to alert authorities to signs of impending volcanic activity. The greatest earthquake of 2017 struck at 6:48 p.m. Mountain Daylight Time on June 16th. The magnitude 4.36 earthquake struck 9 miles north of West Yellowstone, Montana. A magnitude 4.8 earthquake struck the center of Yellowstone, close to the Norris Basin on March 30th, 2014, at 6:34 a.m. Thankfully, there were no reports of damage. Since February 22, 1980, this has been the strongest earthquake. The earthquake was felt in the Montana communities of Gardner and West Yellowstone. It was the greatest earthquake since the 4.8 magnitude on March 30, 2014. On June 15, 2017, at 5:48 p.m. local time, an event with a magnitude of 4 occurred. The 4.4 magnitude earthquake was felt by approximately 120 people in Yellowstone National Park and the nearby settlements, including West Yellowstone. This earthquake was part of a swarm of powerful earthquakes in the same area. The Maple Creek swarm began on June 12, 2017, and lasted until October that year. A cluster of over 2,475 earthquakes was detected 6 miles north of West Yellowstone, Montana, and on the park's west border. These types of earthquake sequences are prevalent and account for nearly half of the total seismicity in the Yellowstone region. The University of Utah, in partnership with the University of Texas, El Paso, and Yellowstone National Park, planted 290 shock detectors in and around the Upper Geyser Basin in November 2017 as part of a study that began in 2015. The purpose of the temporary deployment, which lasted several days, was to record shock signals from diverse thermal characteristics. The 2017 study focused on Geyser Hill, attempting to discover the underground root of thermal phenomena and determine if they originate from a similar reservoir or separate sources. In 2015, similar maintenance was done on Old Faithful's plumbing infrastructure. A magnitude 7.3 earthquake shook the park on August 17, 1959. It claimed 28 lives as a landslide ripped through a campground and severely damaged the ingenious systems of neighboring Yellowstone National Park, notably Old Faithful Geyser. More than 80 million tons of rock fell, stopping a river and creating Earthquake Lake, which still exists today. The quake was the second largest in the lower 48 states that century at the time. It is still the greatest historical earthquake in the Intermountain West, bounded east by the Rocky Mountains and west by the Cascade Range in the Sierra Nevada. Sapphire Pool, a previously peaceful hot spring in Yellowstone's Biscuit Basin, began erupting over 200 feet high just a few days after the quake. The eruptions destroyed the basin's famous, biscuit-like structures. Steamboat, the world's tallest geyser, erupted in 1961, less than 3 years after the 1959 earthquake, after a 50-year hibernation in Yellowstone's Norris Geyser Basin. The U.S. Forest Service opened the Earthquake Lake Visitor Center 8 years after the earthquake. The center is just across from the original slide, which is still visible today, on Highway 287. The center is located around 27 miles from West Yellowstone and is open from May to September. The fault scarp can now be seen north of Highway 287 in the Cabin Creek Scrap area, 23 miles northwest of West Yellowstone, and in Red Canyon, about 17 miles northwest of town. The trailhead is roughly a 10-minute drive from the Red Canyon turnoff, and the scarp is about a 20-minute climb away. The building destruction site is 21 miles northwest of West Yellowstone on the north shore of Hebgen Lake. This little visited location is accessible by an ancient highway and a short walk to the buried Hillgard Fishing Lodge. The canyon's most visible feature, the slide, is still mostly barren with scattered tree regeneration. Highway 287 provides a clear view of the harsh, barren mountainside. The trees that previously bordered the Madison River now lie gray and soggy at the bottom of Earthquake Lake, protruding from the surface as a reminder of what once was. Interestingly, seismic activity in the park has recently increased, with hundreds of earthquakes recorded within a few days. The increase has reignited discussions about the possibility of a future eruption. The scientist in charge of Yellowstone said that seismic activity in the area is usually sporadic. About 2,400 earthquakes occurred in 3 months between June and September 2017, some of which reached magnitudes of up to 4.4. Scientists and experts have begun to watch seismic activity in the parks closely and casually as public concerns and public awareness grow. At the heart of this concern is the caldera. The likelihood of a catastrophic eruption is considered low. However, recent seismic activity in the area has prompted further investigation into the geological stability of the area. The volcanic history of the region provides valuable information about its behavior. It makes it easier to predict the timing and size of future eruptions. But Yellowstone experts say that doesn't mean it's completely accurate. Although seismic monitoring and geospatial analysis provide valuable tools for monitoring changes beneath the Earth's surface, the complex interplay of geological forces makes accurate forecasting a formidable challenge. Another challenge is the inability of experts to predict the type of expected eruption. Eruption scenarios range from small steam explosions to volcanic cataclysms. As news of the recent earthquake swarm spread online, social media platforms were abuzz with speculation, concern, and even apocalyptic predictions. The public's collective consciousness was scrambled in a way that revealed a deep anxiety and fascination with this sleeping giant. Many users expressed doomsday sentiments with dark humor. Others believe it was the final stage of the global climate problem we are facing. Still, others believe that if a volcanic eruption wipes out only a small part of the world, others will not escape a large amount of ash in the air from sulfur showers. Amid this widespread panic, the U.S. Geological Survey and the Yellowstone Observatory acted as a voice of reason and scientific basis. They reminded the public that while the seismic activity was alarming, it did not necessarily mean an eruption was imminent. This reminder helped provide perspectives based on scientific data and expert analysis. Despite these assurances, the eruption could bring cataclysm to the world. Another major concern is the lake eruptions within the park. These outbursts have caused terrifying happenings, which send waves of shock around the world. What are the consequences of these eruptions? Is the lake's next eruption the end of the world? Yellowstone Lake is the largest body of water in North America and the second largest in the world at such elevation. The lake is fed by many streams and rivers, including the Yellowstone River, which enters the lake in the southeast and empties at the north end. The lake is quite deep, with an average depth of 140 feet and 43 meters, and a maximum depth of about 390 or 410 feet with 119 or 125 meters. Yellowstone Lake has many interesting features. The lake has two branches, the southern and southeastern branches, which resemble southern fjord-like extensions outside the caldera of the roughly oval main body of the lake. West Thumb is a button-like protrusion on the west side of the lake that was formed by a relatively small eruption of the caldera about 150,000 years ago. West Thumb Geyser Basin is the oldest of Yellowstone's hydrothermal features, and was first described in 1827 in a Philadelphia newspaper. The lake is home to many waterfowl, including Canada geese, several species of ducks, American white pelicans, and the rare trumpeter swan. The lake is also a popular place for trout fishing, although native trout species are threatened by predators, especially lake trout. Therefore, fishing for native species is prohibited, and fishermen must follow a catch-and-release policy. If Yellowstone Lake were to erupt, the surrounding landscape would become a fiery inferno as streams of molten lava flow down the slopes of the caldera. Communities in the shadow of the park would be threatened with destruction. As their homes and livelihoods are consumed by the relentless advance of the lava flow, the effects of such destruction will be felt for generations to come, renewing life in the region. If this ruin were to open, the furnace would release a flood of ash and debris into the atmosphere. This would cover the environment with a suffocating blanket. Cities hundreds of kilometers away will remain in the dark for days or even weeks. The sky would be covered in darkness and the sun would be covered. These fine particles would enter homes, airways, and possibly waterways. If that happens, we may be dealing with a major public safety threat that we never had to deal with before. This would have a severe impact on the global climate by injecting sulfur dioxide and other toxic gases into the atmosphere, potentially triggering a phenomenon known as a volcanic winter. This phenomenon happens when sunlight is blocked from reaching the Earth's surface, leading to a temporary cooling of the planet. This cooling effect would disrupt agricultural patterns, trigger food shortages, and worsen existing environmental challenges, further amplifying the impact of the eruption on a global scale. In the wake of this devastation, communities will face the daunting task of rebuilding and recovering. Emergency services would spring into action, providing aid and assistance to those displaced by the eruption, while scientists work tirelessly to monitor the volcano's activity and mitigate the risk of future eruptions. Although they may seem distant, geological history has shown that sleeping giants can awaken. The move to monitor the volcano's activity and earthquake signs has begun, and an observatory has been set up. What is the capability of this station? How effective is it? The technology that monitors earthquakes. The Yellowstone Volcano Observatory is a collaborative project organization of the United States Geological Survey, the University of Utah, and the National Park Service. It is the main center for monitoring and studying Yellowstone's volcanic activity. The team consists of experts specialized in geophysics, geochemistry, and geology. The observatory plays a key role in providing timely warnings to the public and rescue workers. The University of Utah seismograph stations operates a network of seismometers throughout the region, whose mission is to detect and analyze seismic activity associated with volcanic activity. By monitoring the subtle tremors and quakes that precede these eruptions, the team can provide valuable information about the inner workings of the system. The research team has developed a comprehensive monitoring plan that focuses on two main areas: nuclear monitoring and hydrothermal. Environment monitoring network monitoring refers to a network of seismometers, GPS receivers, and other devices used to monitor subtle movements in the Earth's crust. By monitoring changes in the Earth's deformation and seismic activity, scientists can detect signs of volcanic activity and estimate the probability of an eruption. Hydrothermal monitoring is the process of closely monitoring the park's many hydrothermal features, such as geysers, hot springs, and fumaroles. These features are fueled by heat from the Yellowstone volcanic system and are sensitive indicators of volcanic activity. By monitoring the temperature, water chemistry, and gas emissions of these systems, scientists can detect signs of hydrothermal vents and assess the potential for volcanic activity. Despite this solid system, experts continue to innovate. Looking to the future as monitoring technology advances, scientists are exploring new ways to improve our understanding of the Yellowstone volcanic system. This will improve our ability to predict and mitigate the risks of volcanic activity. From the development of automated aerial vehicles equipped with hot cameras to the integration of artificial intelligence algorithms for real-time data analysis, the future holds endless opportunities for innovation in volcano monitoring. But these innovations are not without challenges. The road ahead is laced with obstacles, from the logistical hurdles of maintaining and expanding monitoring networks in the remote and rugged terrain to the uncertainties associated with predicting volcanic eruptions. Mapping and deploying observatories in this region requires scientists to navigate and go through rough roads and desert landscapes in search of data. It is also an incredibly delicate balancing act to maintain and expand the surveillance network in the region. From acquiring and transporting equipment to commissioning and maintaining monitoring stations, each step of the process can become a logistical challenge if not handled correctly. Scientists who monitor Yellowstone National Park face many challenges due to its remote location and harsh weather conditions. They have to use special vehicles like helicopters and snowmobiles to reach monitoring sites. Plus, they have to deal with extreme temperatures, strong winds, heavy snowfall, and unpredictable weather conditions. The weather can be dangerous for both monitoring equipment and workers' lives. Winters can bury monitoring stations under layers of snow and ice, while summer storms can destroy delicate instruments, leading to frequent maintenance and repairs. Despite the importance of the project, the observatory working on it is struggling with limited resources and financial constraints. Acquiring, commissioning, and maintaining equipment is expensive, and researchers have to stretch their budgets to breaking point. This leads to regular thinning of monitoring networks, creating gaps in coverage that leave critical areas vulnerable. Fortunately, through collaboration, innovation, and unwavering commitment, scientists and researchers can overcome these challenges and continue to protect the park for future generations. One of the iconic inhabitants of Yellowstone National Park is bison. Recent research has revealed a fascinating relationship between bison behavior and the geological activity beneath Yellowstone Lake. In the days before earthquake events, bison herds showed usual behavior such as increased restlessness and migration away from areas of increased geological activity. These behavioral changes are potential warning signs of impending volcanic activity, and it provides valuable information about the complex interaction between natural behavior and geological events. By closely observing and documenting the movements and behavior of bison herds, scientists can gain valuable information about the underlying processes that cause volcanic activity and seismic disturbances. Understanding the effects of this complex network of natural behavior and geological events will help us identify the effects of volcanic disturbances far beyond Yellowstone Park. From driving out wildlife populations to disrupting ecosystems and food chains, volcanic activity can change our world in ways we have yet to discover. As we understand the relationship between natural behavior and geological events, we will be able to use nature's wisdom to support our efforts toward a sustainable future. Does this mean we need to throw out hundreds of billions of dollars worth of hardware and get started? Only time and more research will tell. But experts have concluded that including wildlife monitoring can be an important strategy for monitoring our volcanoes. Using the collective knowledge and expertise of scientists and nature experts, we can develop proactive measures to protect human and animal populations from potential threats from geological events. It may be true that wildlife detects seismic activity long before humans and migrates accordingly. We seem powerless against the raw power and untamed beauty of Yellowstone Lake. It reminds us of the delicate balance that sustains life on Earth. It is also good to remember that in the face of uncertainty, some caldera guards stand and are vigilant in their efforts to control and mitigate the risk posed by it. What do you think about these natural and environmental hazards? Leave your thoughts in the comment section, while at it also like, share, and subscribe for more related content.